Hi, and welcome to this video on quadratic patterns part 1, brought to you by the answer series. The general formula for a quadratic pattern is very similar to the general formula for a parabola. In this particular case, we are working with a quadratic pattern given by the formula minus n squared plus 6n minus 5. That means that if we plot the points associated with this pattern, we will have a parabolic curve with a maximum value. If we have a closer look at that, when 1 is substituted, we get a result of 0, which we're going to plot. When 2 is substituted, we get a result of 3. If we continue the process, substituting 3 gives a result of 4, substituting 4 gives a result of 3, substituting 5 gives a result of 0, and finally substituting 6 gives a result of minus 5. Very important to note for problem-solving questions, two things. Number one, a quadratic pattern has a symmetry line. Secondly, this particular quadratic pattern has a maximum value because the coefficient of n squared is negative. Also important to notice in a pattern, particularly in this quadratic pattern, is the fact that n can only be a positive whole number. It cannot be negative, nor can it be a fraction. The value of Tn, which represents the value of the term, can be any real number. The theory behind quadratic patterns is as simple as ABC. If we take the formula for a quadratic pattern and we substitute 1, we end up with a plus b plus c as the value of the first term. Taking the same formula, this time substituting 2, we end up with 4a plus 2b plus c, the value of the second term. Substituting 3 for n gives us 9a plus 3b plus c, the value of the third term. And finally, substituting 4 gives us 16a plus 4b plus c, the value of the fourth term. Now, if we take the difference between the first two terms, we get the first of the first difference row, 3a plus b. If we take the difference between the second and third terms, we get the second first difference. And if we take the next difference between the third and fourth terms, we get the third difference in the first differences row. Those differences form a linear pattern, which is going to be very important in many of the questions that we tackle going forward. The differences between these first differences is a constant value, always represented by 2a. So we are going to be looking for values first to do with a, then to do with a plus b, and then to do with a plus b plus c. Hence, this is as simple as ABC. I want you to pause the video and try example 1 on your own, remembering that 2a always gives you the second difference, 3a plus b gives you the first of the first differences, and a plus b plus c represents the value of the first term. So, how did you do? Did you realize that if you worked out the differences between your terms, you would have a 0 difference, then minus 4, then minus 8, and then minus 12. And building on that, you would get minus 16, so that your next term would be minus 34. And then you would get minus 20, so that your next term would be minus 54. Using our ABC method, we are going to generate the formula for question 1.2 by doing the following. We're going to start by recognizing that 2a is equal to minus 4. We are going to find that a is equal to minus 2. Then we are going to take 3a plus b equal to 0, and using that information and substituting the value of a, which we know to be minus 2, we are going to work out that the b value is 6. Now we are going to take the a value of minus 2 and the b value of 6 and make use of the fact that a plus b plus c has a value of 6 to work out that c is equal to 2. So we've been able to work out our formula by substituting a, b, and c. The nth term is given by minus 2n squared plus 6n plus 2. To work out the 50th term, we take the value of 50 and replace n in the formula with 50 and calculate that the 50th term has a value of minus 4,698. The reverse logic to that would be when we are given the value of the term, so in this case, in 1.4, we are given the value to be minus 1,398, and now we have to work out the possible values of n. So we are going to equate the formula with the value of the term. We're going to put all of that onto the same side of the equation so that the equation equals naught, in other words, standard form, and put that equation into its simplest form. We will then either factorize, or we will make use of the fact that we can see that the value of A is 1, the value of B is minus 3, the value of C is minus 700. Careful substitution into the quadratic formula will give us the exact same results of n equal to 28 or n equal to minus 25. In both cases, we need to show both answers, remembering to discard any negative or fraction answer. So the only result that we will end up with is n equal to 28, and from that we conclude that the 28th term has a value of minus 1,398. Pause the video, try all of the questions on your own, and then when you're ready, we will go through them together. In question 2.1, we are going to work out the differences, and having established that the differences are 10, 8, 6, we carry on that downward trend of 2. So we know that the next difference will be 4, and using the 35 and the 4, we generate the next term of 39. We continue with our differences, dropping by yet another 2. We add 39 and 2 and create the term of 41. So the next two terms are 39 and 41. Now, in order to work out our formula, we are going to go and connect 2a with the second difference value of minus 2 and use that information to find out that a is equal to minus 1. Then we are going to go and find 3a plus b equal to 10, because that's the value of the first difference. We're going to substitute the value of a, which we have already found, into the formula and work out that our b value is equal to 13. Then we are going to go one more time back to the formula a plus b plus c equal to 11. We're going to use the values of a and b, which we've already found, minus 1 and 13. And this time we are going to work out that our c value is minus 1. So substituting those results into our formula produces an outcome of Tn equal to negative n squared plus 13n minus 1. In 2.3, we are going to use that formula to work out the value of the 13th term. So if we substitute 13 in place of n, we will end up with a result of minus 1. So the 13th term has a value of minus 1. In 2.4, we are asked what is the maximum value of the pattern? What is the largest value that any term can have? To understand this question, we need to think back to an earlier discussion about the fact that a quadratic pattern has a parabolic shape. Given that our quadratic pattern has a negative coefficient for n squared, we are sure that this parabolic shape gives a maximum value. To answer this question, we simply need to find the value of a, which is minus 1, and the value of b, which is 13, taken from the formula coefficients of n squared and n. We substitute those values into the formula for the axis of symmetry, given by n equals minus b over 2a. Careful substitution produces the result of 6,5. Now we know that n cannot be 6,5, so we choose the integers closest to 6,5. Because 6,5 is exactly halfway between 6 and 7, we don't have to test to see which one will work. Because of symmetry, we know that both 6 and 7 will produce the same answer. In a different situation, we might need to take the integer on either side and check to see which one produces the maximum. In this case, we are going to use 7, and when we substitute 7, we get 41. So we are confident that the maximum value of this pattern is 41. Hence is a big hint. It means that we are going to use what we have just done to work out the values of n for which Tn is equal to 100. Now, you should be thinking about this and saying, hang on, what are they talking about? we've just worked out the fact that Tn is 41 is the maximum value. So how can they ask us to find the position of a term that produces a value of 100? Well, they can ask us, but we can't answer because there is no such value. So the correct solution here is there is no value of n for which Tn will be 100. And the justification is simply explaining that the maximum is 41. They have come back at us with a different question, asking us to explain differently why this is the case. And they've given us some help by telling us to use quadratic theory. Quadratic theory means that we are going to use delta, which means we are using b squared minus 4ac. So if we look at our information, we have a quadratic formula, and we are supposed to be making that equal to 100 to solve for n. So we set it up as an equation, put that equation into standard form so that it equals 0. Work out that a equals 1, b equals minus 13, and c equals 101. Using those values, carefully substituted into b squared minus 4ac, we get a result of negative 235. That tells us that delta is negative, which means that the roots are non-real. Hence, Tn cannot be equal to 100.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.